In this lecture, we'll be studying about context switch. So we'll be seeing what is a context switch, when does a context switch occur, and what does a context switch do in an operating system. Alright, so let's see. What is this? So here it says, interrupts cause the operating system to change a CPU from its current task and to run a corner routine. And such operations happen frequently on general-purpose systems. So in the previous lecture, when we studied about processes, and when we saw the way processes were executed, we saw that when processes are being executed, if an interrupt occurs, or if a process of higher priority comes, then that particular process has to stop its execution. And it has to allow the process that is causing the interrupt to execute first, and after that is completed, the previous process can resume its execution. So interrupts cost your creating system to change the CPU from its current task and to turn the corner routine. So what does this mean? We know that when processes are being executed, the CPU is being assigned to that particular process. So when an interrupt occurs, the CPU has to be assigned to that process or that thing that is causing the interrupt, so that that will be executed first. And when that is completed, the CPU can be reassigned back to the process that was previously been executed. So that is what we mean by this line. And this kind of operations, they frequently happen on a general-purpose system. So when an interrupt occurs, the system needs to save the current context of the process currently running on the CPU, so that it can restore that context when its processing is done, essentially suspending the process and then resuming it. And the context is represented in the PCB of the process. And what is PCB? It is a process control block. So as I told you, when a process is running, and if an interrupt occurs, then that process has to stop its execution. And then the interrupt or the process causing the interrupt has to be executed first. So when an interrupt occurs, the process that was currently running needs to save its context to the CPU. Now, what do you mean by context? So context means it consists of the current state or the current information about that particular process. And why we need it is because when the process will resume its execution, it needs to know where did it stop executing at that particular moment, so that when it resumes, it will know from where it has to resume its operation again. Alright, so that is what we mean by the context. So let me take a real-life example to make you understand this. So let's say that you are in your home reading a book. You are reading a book of your choice, and you are just going through the pages, reading that book. So reading the book is a process that you are doing. Now when you were reading that book, suddenly your mother calls you from the other room, and she asks you to do something. She calls you and says, "Please come and help me with this." Now your mother calling you is interrupt. You are being interrupted while you are reading the book. Now you need to execute that task. That means you need to go and help your mother, because that is an important process of higher priority than reading the book. So what will you do? You will take a bookmark, and you will place it on the page on which you were reading, and you'll close that book, and then you will go and help your mother or do the work that your mother said. So what did you just do? You, by placing the bookmark on that book, you save the current context of the process that you were doing. And why did you do that? You did that because you know that after you finish helping your mother, you will come back and resume reading your book. So at that point, you need to know where did you stop reading the book so that you can resume from that particular chapter or from that particular page. So you kept that bookmark. So keeping that bookmark is saving the current context. And then you go, and then you help your mother. And when the work that your mother told you is completed, you will come back, and you will resume reading your book. That means you will resume the process that you suspended. Now you know from where you have to resume reading because you kept that bookmark. So with that example, Try to visualize context switching. Now the context is represented in the PCB of the process. Now PCB stands for process control block, which we studied in the previous lecture, and we saw what are the things we have in a process control block that represents a particular process. So all those things in the PCB, like the state of the process, the memory, the registers that it is using, all those things will be stored in the PCB. So with the help of PCB, we can know what is the current context or the current status of that particular process, so that when it is saved from the CPU, and when we go and execute another and process, come back, we know that from where we have to resume. So that is the concept of context. So switching the CPU to another process requires performing a state save of the current process and a state restore of a different process. Now visualize an example that I took about you reading a book and going to help your mother, and try to understand this definition. So when we are switching the CPU to another process, that means when you are going to do another task, you need to save the state of the current process. You need to make sure to save the state of the current process, so that when you come back to this process, you know from which part you need to resume the execution and a state restore of a different process. So a different process is going to be executed. So that process might be a new process or a partially complete process. So that state of that process has to be restored, so that you know even this process from where you need to continue it execution. So we perform a state save of a current process and the state restore over different process, and this task is known as context switch. Alright, so this task is known as context switching, where we save the state of one process and we restore the state of another process when a particular process is interrupted by another process during its execution. So we see that when one process is executing, another process interrupts it, and that process which interrupts has to be executed first. So the current process has to stop its execution, and it has to save its context, and the process that is causing to interrupt has to be executed. So that is what we mean by context switch. We are switching from one process to another process, and then the context of these two processes are stored in the CPU. That means one is saved and the other one is restored. So I hope with that you got the idea of context switching. Now, before we end, there are a few more things that you need to know about context switching. So these are the points that you need to remember. Context switch time is pure overhead, because the system does no useful work while switching, and its speed varies from machine to machine, depending on the memory speed, the number of registers that must be copied, and the existence of special instructions, such as a single instruction to load or to store, or registers. And typical speeds are few milliseconds. So the main important thing you need to remember is context switching time is pure overhead. Now what do you mean by overhead? Overhead means the cost that is involved in doing something. Now we are not talking about the financial cost over here in terms of operating system. When we say cost, cost can mean many things, like the resources that we use, the time that we spend, and so on. Now, we say that context switching time is pure overhead because the system does no useful work while it is switching. So, we say that when the context switching is happening, the system is not doing any useful work while the switching is happening. But you may say that, well, context switching itself useful is a task. Yeah, it is. We need to have context switching, and context has switching to be performed. But when we discussed about the objectives of multi-programming and time sharing and all that, we saw that our main objective is to have some process running at all times so that we can maximize the utilization of our CPU, and hence we can make efficient utilization of our resources. But when the context switching is happening, we see that the CPU is switched from one process to another. So at that moment, only the switching parties working, only the switching parties going on. There is no process executing at that instant when the switching is happening. So that is why it says no useful work is done while switching, and then the speed of switching it varies from machine to machine, from hardware to hardware, and on many factors, as it is mentioned in this second point, and the typical speeds are few milliseconds. So the typical speed that consumed for switching may be a few milliseconds. So these are some of the points which you need to remember about context switching, and always be clear about the main idea of switching when one process is suspended and another process is executed due to an interrupt. At that time, the context is switched, and that is what we mean by context switching. So this is a very important term in operating system, and from now on, when we use this term, I hope you will have a clear idea about what this actually means. So that was about context switching. I hope this was clear too. Thank you for watching, and see you in the next one.